How's it going, everyone? I hope you guys are having a great day. Welcome back to another Web Dev Junkie video. So I'm not going to share my webcam today because my kid's asleep, so I'm trying to keep the lights off. In this video, I am just going to revisit a problem that I solved for you all. Someone asked in the comments if I could explain what the complexity of this problem was, and I tried to break it down for him in the comments, but I figured a video might do a better job. So before I actually dive into breaking down the complexity, just know that I haven't actually done stuff like this since like 2012 or 2013 back in college. So I don't really know 100% if I'm doing this right. So feel free to leave a comment below if I screwed this up. And like always, be sure to like this video because it helps my channel grow. And if you're new to this channel, be sure to click that subscribe button if you want more content like this in the future. So here is the algorithm. We have an array of words and we have an array of keypads. So if I break this algorithm down, I'm going to basically denote W as being like the length of the words and K for being the length of the keypads. In fact, I probably should have just done this. All right, so those are our main arrays. And if we look here, we're doing a map, right? So a map function in JavaScript is going to loop over every element of that array. So in this case, we know that our algorithm is going to do something. So K times something. And what I've learned is that whenever you have like a loop, whatever is nested between these blocks is going to basically be a parentheses here. Okay, so it's going to be K, which is the length of the keypads, times the complexity of whatever is nested inside of it. So I think what was kind of tripping him up, and it could be kind of confusing, is that I'm doing a lot of other methods on all these things. So I'm doing like a pad.split, and then I'm doing like a for each, and then I'm doing like a filter, and then a for each. But it really just boils down to like, unless you're doing another nested loop, you're just going to add up the constants. Okay, so in this case, pad, we know is always going to be 7 characters. 1, 2, 3, 4, 5, 6, 7. So in this case, it's K times 7. So we do a split on that to get 7, and then we do a for each on that again. So basically, that's going to be plus another 7. And then we come down here when we have words, right? So we do a filter on the words, which is going to end up being the length of W, so plus W. And then we do a for each. Okay, so that's going to be another plus W. Now, if you're confused about this part, this could have been like split up. I could have just said like const new words is equal to that times filter. And then I could say new words is equal to that for each over that. So this is, again, this is why this is a plus. It's a W. This is the first W plus another W, which is this. Okay. And so as you can see here, we're going to do a for each over this other W. So that's going to be another times, right? Anytime you have a nested loop, the inner block is going to be what's inside the parentheses here. So if we kind of break it down inside of this and figure out, okay, what actually is happening inside this for each, we can see that we take the word, which in the problem statement, it says a word can be at most 7 characters. So we could just say 7. So I could do 7 plus, and then we do a reduce over that, right? So again, the most the word can ever be is 7 characters, so we're basically doing another 7 steps, I guess. So take the word, loop over it 7 times for every character, and then loop over it again to run the reduce function, and then run this, which doesn't really count. So ultimately, I think this is the big O notation, but when you're doing big O, you want to remove the constants, right? So I could kind of break this down a little bit more just to make it seem a little bit easier. I'm going to add the constants together. So 2 times W. Typically with big O notation, you need to remove the constants and kind of reduce it. So I'm just going to go ahead and add some constants together to make sure we're on the right path. And times that by 14. Okay, so hopefully that makes sense so far. We can keep reducing this some more. So we could distribute the K. So we could do this. Pretty much times K by everything. The W times K times 14. This is going to be a plus. And then we could add stuff together. So this is a WK and this is a WK. If you know anything about algebra, you could simply add those terms together and get 15. And this one would stay untouched, right? So K times 14 plus WK times 15. We put a times there. So if I haven't lost you yet, again, what you need to do in big O notation is remove any constants. So the 15 needs to go away and the 14 needs to go away. So I can say K times the W times K. And or sorry, this is going to be a plus. Okay, so that is kind of our final big O. But again, I'm pretty sure that you're supposed to get rid of this. You might need to keep it. I don't really know. But I think with big O, you're supposed to like round up to the highest algorithm. So in this case, this K would go away. And we could just pretty much assume that it's going to be like this runtime. And then lastly, if you wanted to kind of round it up to the most complex algorithm, this would be, you can kind of pretend like the W would be a K or K would be a W, like this. If you make the terms the same, you'd end up getting something like that, okay? Which would just be a big O of n squared. Sorry, it's hard to type, my lights are off. So yeah, this was the breakdown of how do I take this, which is a loop with filters and splits and for eaches and other stuff like that, with another nested for each that has split and reduce. It seems like it would be a lot more complex than n squared, but if you really break it down, if assuming I did this correctly, this is how you would figure out the time complexity of it. So again, if you think I did anything wrong with this, feel free to leave a comment, call me out. I'm pretty sure this is close to how it's working. And another way to check is I could just basically, instead of splitting for each, I could probably just remove or replace these and just like run a counter, right? Let's do that real quick. So I'm going to put like a let sum is equal to 0. And then for every time I do any type of like map or reduce, I'm just going to add to the sum. So this one is going to be, again, I'm going to run sum plus plus. Yeah, so then I could change this to a for each and basically do the same thing. So we did a for each there. Okay, let's try it again. So we do a for each here. So we need to say for each. But this one, we're not actually going to like do a sum because we need to do the sum on these, right? So we're going to do a for each on the split, for each on the reduce. Get rid of this. Probably need to keep word here. And then that's just not needed. All right, so let's print out sum and see what this actually works. All right, so pad is actually a string, so I can't do a for each on it. So what I'm actually going to do is I'm just going to set this to a hard-coded array, like say new array of length 7, and fill it with characters, I guess. And I think that should fix the issue, I hope. Word is a string, and I probably need to like hard-code it to an array of, let's say 7 characters. So this is kind of a mess, I'll be honest with you. Okay, we got 295, okay? So to see if our complexity actually kind of sums up to that, we could just plug in K and plug in W here. So what we could do is say K is 5. Let me zoom in here. So see, we do 5 times 7 plus 7 plus 3 plus 3 times, I think this is 14. Let's look at this. Yeah, this is 14. So if I run it, we get 295. So if you notice here, we got the exact same, basically, lines that were executed, or the sum, based on this formula. So I'm pretty sure this is a correct formula. And then if you want to kind of just do the simplified form, 8 times k, so that would be 25, so obviously that wouldn't work. But if you do something larger, like let's say your keypads was 100 and your words was 100, then you kind of have a better understanding of like what the total execution time is, right? So sorry about this. This was kind of a hot mess to figure it out, but I hope that helps you understand of like how you can actually like kind of figure it out by changing the code a bit and seeing what the sum is. So yeah, if you like this video, be sure to give me a thumbs up. And also if you're new to the channel, be sure to click that subscribe button. And like always, leave me a comment if you think the way I broke it down was incorrect. All right, have a good day, y'all.